In this video, we will review the relationship between angles and arcs of a circle. There are four situations that we have learned about, and they are: sometimes the vertex of the angle is at the center of the circle, and in that case, the angle is equal to the arc. Sometimes the vertex is on the circle, all right, that's called an inscribed angle, but in that case the angle is half the arc divided by 2. Or if you flip that around, that means the arc is double the angle. Sometimes the vertex is just randomly inside the circle, all right, but not necessarily at the center, just anywhere in the circle. In that case, we have this relationship because we have two arcs now, all right, we have arc X and we have arc Y. So the angle is arc plus arc divided by 2 in that case. And then finally, sometimes the vertex is outside the circle. And in that case, we still have our two arcs. But instead of doing arc plus arc divided by 2, we do arc minus arc divided by 2. And you should do the big arc minus the small arc so you don't get a negative number. All right, so just pay attention to each problem. Ask yourself, which one of these situations are we in? Is it at the center? Is it on the circle? Is it in the circle? Or is it outside of the circle? So number 15, this angle is clearly outside the circle. All right, so I'm going to put out right there. When we're outside the circle, that's when we do angle is equal to arc minus arc divided by 2. The angle itself is what we're looking for, so I'm going to go ahead and say X is equal to. Now, be careful to make sure you do the big arc minus the small arc, so that would be 80 minus 32 divided by 2. Can someone just tell me the answer for number 15? Just straight up. 24. All right, does everybody agree with that? Anybody have any questions? For number 16, this angle is at the center. That means the angles and arcs will all be the same. We're supposed to find the measure of arc FG. So let's keep that in mind. So we're looking for FG down here. It looks like we have a semicircle happening. Okay, so if we look at this right here, DG is clearly a diameter. And we have the 90 degrees and we have 74, so we should be able to just subtract that from 180. So if we do 180 minus the 90 and the 74, so minus 90 minus 74, that gives us 16. So that's why arc FG should be 16 degrees. Any questions on number 16? For number 17, this angle is inside the circle. It's not at the center, it's just randomly inside the circle. And the formula for that is angle is equal to arc plus arc divided by 2. Well, the angle is what we're looking for, so that always makes it easy when the angle is what we're looking for. All right, so this does have one little trick to it. Please understand that the 30 and the 110, one of those is not the right arc that we need. So really focus and make sure that you're picking the right arcs. Because look, here's the angle that we're trying to find. All right, now if that's the angle that we're trying to find, then these are the intercepted arcs. It's making sort of an hourglass shape. Look for the hourglass. So which one of these arcs that they gave us is not part of this hourglass? The 110, all right? So we will not do 110 plus 30. The 30 is good, but we need to find this purple arc up here at the top. So how am I going to do that? Well, can you see that we have a diameter happening right here? Okay, this is a diameter. All right, that means that we have a semicircle on this side. So what do these have to add up to be?
180.
They got to add to 180. So you can just do that in your head, can't you? So what's the purple arc then? 70. So this must be 70 because the 110 and 70, that makes 180. So that's what we're going to use. We'll use 70 plus 30 divided by 2. So that's 50 degrees. Any questions about number 17? So for number 18, this angle is clearly outside the circle, out. So the formula for this situation is angle is equal to arc minus arc divided by 2. And again, I hope you're finding yourselves beginning to memorize these formulas, all right? Because when the quiz comes, you're not going to be given the formulas. So the angle is what we're looking for, so that's great, that's helpful. So I'll go ahead and put X for that. Now these two arcs. Again, a common mistake would be to use the 170 and the 134. Again, one of these arcs is not the correct arc to use. See if you can tell which one is no good. Okay. So look, one of the arcs is 134, all right? See how that is inside the angle? So that's an intercepted arc. That one is good. But the other arc that I'm going to need is the other arc that is inside the circle that I'm drawing in green right here. This 170 is not intercepted. It's outside of the angle. So the 170, I'm not going to use it. So how do I find the green arc? That's the one I really need.
180.
Not 180, because I don't actually know this is a diameter. It does look pretty close, but actually I can tell, look at this, 170. If this was a diameter, what would that be?
180.
It would be 180, right? If this really was a diameter, that would be 180. So this is not a diameter, so instead, what do I do?
Add enough to subtract from 360.
Yes, we got to go all the way to 360, all right? Because we know everything except for the green, the whole circle except for the green. So we should be able to subtract from 360. So that's why I'm going to go 360 minus 170 minus 134. 56. So that means that the green arc was 56. Okay, so now I can go on with the problem. Big arc minus small arc. So 134 minus 56. Notice once again we did not use the 170 in the calculation. So help me out. Can somebody just put that in your calculator and tell me what you get? What was it? 39. So X turns out to be 39 degrees. Any questions about number 18? Notice that for problem number 19, this angle is at the center. That means the angles and arcs will all be the same. So we are supposed to find the measure of arc ED, which is this guy right here. All right, I see we have a diameter happening. That's going to help us out. So if this green chord is a diameter, that means we have a semicircle over here. So I should be able to find arc ED by subtracting 90 and 52 from 180. All right, so if I go 180 minus 90 minus 52, boom, 38. All right, number 20 is interesting because we have a combination of angles that are at the center. So this 120, that's at the center. But then ultimately the angle that we're looking for, maybe I'll change colors for that. This angle is simply in the circle. It's not at the center. So it's a combination. Let's use the fact that this 120 degrees is at the center. Let's use that fact. So if that angle is at the center, that means the arc is going to be the same measure. So that means this arc is also 120 degrees. All right, I'm talking about this arc that I'm about to color in green. All right, this is 120. Okay, now let's move on to the actual angle that we're supposed to find. Let me color that angle in so it'll be more clear. All right, so this angle that I'm drawing in red, this is the angle that we're being, whoa, that's not a line. Try that again. I say this angle that I'm coloring in red is the angle that we're supposed to find. Okay? Now, this is inside the circle. So the in formula goes like this. Angle is equal to arc plus arc divided by 2. So we need arc plus arc. One of the intercepted arcs is shown here in green. The other intercepted arc I'm drawing here in purple. All right, those are the two arcs. See the hourglass? If you look for the hourglass or the bow tie, it helps you pick the correct arcs. So the angle is what we're looking for, so we can just go ahead and say x. And the arc plus arc, that's 120 plus 40 divided by 2. So that's 160 divided by 2, so that's 80. 80 degrees. Any questions about number 20? All right, number 21. This angle is outside the circle, out. So the outside the circle formula goes angle is equal to arc minus arc. Somebody's memorizing these. All right, good job, Karem. Divided by 2. The angle is what I'm looking for, so that's helpful. X equals arc minus arc divided by 2. Now, got to be careful. One of the arcs that I need is currently missing. So understand this. This green arc is one of the intercepted arcs. All right, you can see how it's fitting snugly inside the angle. This purple arc is the other arc that I need. They didn't give me the purple arc, so I need to do a quick calculation to find it. Somebody tell me, what is the calculation that I must do to find the purple arc?
360 subtract 70 minus 130 minus 1.
Exactly. Subtract all that mess from 360 because it's the whole circle except for the purple. So we can just do 360 minus 105 minus 130 minus 70. Boom. 55. Okay, so the purple arc is 55. So now we can go on with the problem. So big arc minus small arc, guys. So 130 minus 55. All right? So you execute that. What do you guys get for the final answer? 30 what? 37.5? 37.5 degrees.
So it's okay to have a decimal point?
Yeah. Oh, for number 22, this angle is at the center. Center. That means the angles and arcs are all going to be equivalent. Can anybody give me a strategy that I could use? Hold on one second. Ari, head up, eyes open, sweetheart. Go ahead, Slade.
You could say they're
They're supplementary. This is a diameter right here. Okay? Because of that, that means this part of the circle is a semicircle. So these two angles have to add up to 180 degrees. All right, so Slade is telling us that we should be able to go 3x plus 5 plus x minus 1 is equal to 180. They have to add up to 180. So like terms, I've got the 3x and I've got x. And then later I have 5 and negative 1. So just combine your like terms. So you're going to get 4x plus 4 is equal to 180. So of course we'll subtract 4 from both sides. So that's 176. And then we'll divide by 4. I don't know that off the top of my head. What's that going to be? 44? Any questions about number 22? So looking at number 23, this angle is at the center. I mean, that's false. This angle is not at the center. It is randomly inside the circle. So that means we're using the formula where the angle is equal to arc plus arc divided by 2. All right, this time they gave us the angle, so this won't be x. We'll have to say 53 is equal to arc plus arc divided by 2. Now these two arcs are expressions. That's okay. So I have 3x plus 3 plus 10x minus 14. I would combine like terms first. So the 3x and the 10x are going together. And the 3 and the minus 14 are going together. So that's going to give me 53 is equal to 13x minus 11 divided by 2. All right, Charlie, what's the next move? Multiply by 2. Yep. Multiply both sides by 2. That way these will cancel each other out. So that's going to give me 106 is equal to 13x minus 11. Then we're just going to be adding 11 to both sides. Okay. 1 second. So of course now we just divide both sides by 13. What's this? Some rent? 9? No, I was expecting a decimal. Ah, sweet. All right, x is 9. Great. All right, number 24. This angle is outside the circle. Out. So when you're in this situation, we know that the angle is equal to arc plus arc divided by 2. Arc minus arc. Sorry. All right, when it's outside the circle, that's when you subtract. So arc minus arc divided by 2. Okay. This one is extra special, so I hope you guys are paying attention. All right, we have these points of tangency right here and right here. Look at the two intercepted arcs that we have. All right, I've got this intercepted arc that I'm showing here in green. And then I've got this intercepted arc that I'm showing in purple. They gave me the purple. They did not give me the green. You should be able to do this in your head, right? What's the green going to be? It's got to be 60, because that completes the entire circle, 360. So now we can do the rest of the problem. Okay, so we can just say the angle is what we're looking for, so x should be 300 minus 60 divided by 2. So that should be 240 divided by 2. So that should be 120 degrees. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.